Okay, so chapter 6, 6.1a, the roots of polynomials. What I've done here is I've zoomed in on what I wrote for those 4 vocabulary words at the top. We're going to use these words a lot in this chapter. You need to know what they mean. Polynomial, well, is essentially something you've seen before. When you think of ax squared plus bx plus c from last chapter, that was a polynomial. We also talked about the words of how to name polynomials by binomial, trinomial, monomial, and then the degree was linear, quadratic, cubic, quartic, and quintic. So you've already kind of seen that. Roots, zeros, solutions, and x-intercepts is the key to this entire chapter. Those words are going to be interchangeable. What they mean, first of all, is x-intercepts of the graph. In other words, the point at where it crosses the x-axis. Then you can also call those roots. You can also call those zeros, and the reason we call them zeros is because we set it equal to 0. You can see that in my example, where I have x squared minus 3x minus 10 equals 0. I factored it, and then you would set each factor equal to 0 to get x equals 5 and x equals negative 2. Those are solutions, which again, whenever you see the word solve, that means you have to set the factors equal to 0. Those factors, again, are your roots, your zeros, your solutions, or your x-intercepts. Those words are interchangeable. Multiplicity is kind of a difficult concept, but what you need to know is the exponent is an even number or the exponent is an odd number. And if it is an even number, then that multiplicity has an even multiplicity. And in a graph, it would bounce off of that point. Whereas if it's an odd multiplicity, it has an exponent of 1, 3, 5, 7, odd numbers, then it goes through the root. We'll get more to that on the next page. Factors are just x minus a, okay, for what we're worried about in this chapter. Now next, I want you to use your Chromebook. I'm going to zoom this back out now so you can see zoom it out so you can see the entire page. Plus I'm going to kind of show you my Chromebook here a second. You're going to use your Chromebook to graph each polynomial function. Using the graph, give the zeros roots of each polynomial. So here's what I'm going to do. I'm going to show you how to do this on my Chromebook. And what I want to do here is I want to plug in number 1. Here's how you do that. If you look over to the left, I've already put y equals in that blank. And I want to show you how to, excuse me, I'm trying to get this, make sure you can see it. There we go. And I'm going to type in the first term. So I've got y equals x, and then what you got to do is you got to go right here where it says a to the b power. Click on that to get your 3, x to the third. Now what you want to do is click the over button, so to the right, and then minus x, and you can see we can actually use this squared button right there for that. We don't have to do a to the b, and then minus 6x. And it shows you a picture of the parabola. And what you'll notice here, again, we're trying to find the roots, the zeros. Well, look, the zeros, the roots are where it crosses the x-intercept. It actually gives us the value of these points. Not that. That I don't want right now. All I want is the zeros, and the zeros are at negative 2, 0, and 3. And so, from that graph, you can pause this at any time, obviously. I'm going to fill in my paperwork here. My zeros are x equals, again, where does y equal 0 is really what we're looking for. Well, it equals 0 at 0, 3, and negative 2. You can see that right in your graph. Okay. I'm going to try number 3 here as well. Okay, so I'm going to go back to my graph here. I'm going to go back up to this. I'm going to exit out of there because I want to put in a different graph, and I'm going to put in again what the second equation says. So I'm going to put y equals, and here they're just written in factor form, so x and then parentheses, which you can either push that button or you can actually use the parentheses button, x plus 4, and then what you'll see is you have to push to the right and do that a to the b power, or just square it because that's what number 3 says. Then parentheses again, x minus 2. It ends parentheses for you, so you can either actually put the parentheses there or you can just press over. I need another set of parentheses for x minus 4. And now what you'll notice again, this is exactly what it says on the book. I'm not asking you to do anything else on this, but to tell me the zeros. So you can see a 0 right there at negative 4. So write that down for number 3. X equals negative 4. I've got another one at 0, so I can put 0. I've got another one at 2, so I can put 2. And I got another one at 4. Now here's the problem. It says give the zeros and list the multiplicity if it is greater than 1. And what that means again is it even or odd? And again, the way it works is if it bounces off, it is even. And if I zoom out a little bit here, I can see, well, what the graph wants to do is it wants to show you that it bounces off, and it's kind of hard to see it from this angle. But actually, if I zoom in a little bit, you can see right here that this is going up to the point and then bouncing off of it, versus going through each one of those. Again, I'm going to zoom in one more time. You can again see it's bouncing off of it, whereas it's going through those points. Okay, so your negative 4 is an even root. And so all we're going to do is we're going to go back to this page. And again, it says if it's greater than 1. Later we're going to do both. But right now, negative 4 is even. Okay, because it bounced off at that point. Ready for something cool here? Actually, you know what? I want you guys to try the rest of these. Try 2, 4, 5, and 6. Plug them into your Chromebook and try them out, okay? I am going to be doing that momentarily. I'm not going to show you on my Chromebook because you can just do that yourself, but I'm going to give you the zeros. So right now, pause it, go and try those on your Chromebook, come back and check your answers. Alright, so I've done these ahead of time, and so I'm just going to give you the answers. This is negative 2, negative 1, and 3 when I plug that in. When I plug in this for number 4, I get x equals 0, negative 4, 2, and 4. It doesn't really matter the order you write them in. Sometimes it's easier to write them from least to greatest, especially when well, let's look at number 5. I get x equals 3, negative 1, and 7. This determines if it's even or odd. That is an odd number, so it's odd. This determines that it's even because it's, again, an even number. For number 6, I'm going to get x equals 0, negative 1, and 1. And again, this determines that it's even. If there's no number there, remember that's a 1, which would make it odd, which would mean it would go straight through it. We'll talk more about that when we get to the graphing here on the next page. Now down at the bottom it says, can you find the roots zeros of the following polynomials without graphing them? Well, look at what all of these have in common. In factored form, if I have 0, negative 1, and 1, guess what? If I set that equals 0, I get negative 1. If I set that equals 0, I get 1. If I set that equals 0, I get 0. That's how I'm getting all these. Look at them all. 0, negative 4, 2, 4. That's how I got those. Do the opposite of that, 3. Do the opposite of that, negative 1. Do the opposite of that, 7. Do the opposite of that, that's how I got 0. Opposite of that is negative 4. Opposite of that is 2, and opposite of that is 4. In fact, if I even go up to number 1, and I factor this, I can take an x out of each one of those, that's the GCF. I can factor that further and have x, and x, minus 3, plus 2. Again, set this equal to 0, I get 0. Set this equal to 0 and add it to get 3. Set this equal to 0 and subtract it to get negative 2. So that's how I can do it all the time. So for the bottom two, go ahead and try it on your own. Pause it a second, try them, come back and check your answers. Okay, so again, I set each one of those equal to 0. I know it's x squared, but I'm not setting x squared. I'm setting the term equal to 0, and I'm setting the other term equal to 0. Well, here I get 0. Here I would subtract 2 to both sides and get negative 2. Again, the exponent only matters whether it is even or odd. I'm going to come back and do that in just a second. I just literally want to set the factors equal to 0. Do the opposite here to get 4. Do the opposite here to get negative 2. Now, it says state the multiplicity if it's greater than 1. Well, I've got a 2 here and a 2 here, which means they are both even, which if we plug that into the Chromebook, it would bounce off it. Okay. In fact, if I remember correctly, it would create a big giant W, the Wu-Tang symbol, if you know that what I'm talking about. Here, again, I got an even there because it's an even exponent, and really that would be odd if it was because it's 1. Okay. Don't let that stuff confuse you, because the next page is just going to be a little confusing. Okay, let's go on to the graphing on the next page. Now, what we're going to do here is we're just going to go through and look at some examples here. Okay? Odd power means, again, that it's x cubed, x to the fifth, etc. Okay? Even power means it's x squared, x to the fourth, x to the fifth. I should have actually wrote this in here too. Also just a singular x. A singular x. Okay? When it is an odd power, it always starts down, ends up. Now you're going to find out something in a couple of lessons, that if there's a negative in front of the polynomial, that it just flips it completely. Okay? Even powers start up, end up. Okay? What you'll notice is, in both cases, they always end up. So if yours doesn't end up, you did something wrong. Okay? Now, what we're going to do here is we're going to talk about increasing and decreasing. I should probably use different colors here, but hopefully you remember from last chapter that increasing means it's going uphill. So right here it's increasing, right here it's decreasing, right here it's increasing, right here it's decreasing, right here it's increasing. And we're going to talk about that shortly coming up. First things first though, what's the easy part of this? What are the zeros? The zeros are just, again, where it crosses the x-axis, where y equals 0, because this is the line y equals 0. Okay? Well, the zeros are at -4, 0, 2, and 4, which, conveniently, are labeled right here on our number line. And the reason I do that, well, first of all, are these even or odd? Well, -4 is even. How do we know that? Again, because on the previous page we said it, when it bounces off, it's even, and it doesn't go straight through it, it bounces off, so that's even. This goes straight through, this goes straight through, this goes straight through. So each of those are odd, and it doesn't matter if they're x to the first, x to the third, x to the fifth, all I want to know is, are they odd? Okay? Now, when I do this number line here, what I'm going to do here is try and find the positive and negative intervals. We know what a positive sign is, we know what a negative sign is. Okay? Now, what I mean by that is, where is it greater than 0? This would be positive. Where is it less than 0? This would be negative. So all of the graph that's above here is positive. All of the graph that's below here is negative. And it's cool because we can just use the x-intercepts as how to do it. In other words, from before -4, well, it's negative because it's down here. From -4 to 0, it's all down here below the y-axis, so it's still negative. From 0 to 2, though, it's above the y-axis, so that's positive. From 2 to 4, it's below the x-axis, so it's negative. And from 4 on to infinity, it's positive because it's above the y-axis. And now the cool thing is, to determine our positive and negative intervals, we just look for positive and negative signs. And here's how we write it. Basically, this interval is from -infinity to -4, then from -4 to 0, then from 0 to 2, from 2 to 4, from 4 to infinity. And how we write it is similar to how we write points. First of all, I'm going to start with our negative intervals because I have one here. This is from -infinity to -4, and from -4 to 0. Those are negative. Again, I know it looks silly because it looks like a point, but this is how we actually write intervals too. We could write x is greater than 0. That's what we've done in the past, right? We've wrote x is greater than 0, but it's not just greater than 0. It would be 0 is less than x is less than 2. That is the same thing as writing 0, 2, like that. This is now just going to be written like that. So same thing from 2 to 4, we can just write 2, 4, like it's a point almost. And from 4 to infinity, we write as 4 to infinity. Why did I put that up here? Because again, that was positive. This one was negative, so I put it down here. Okay? Now, local maxima and minima is really the bottom of hills. And let's write that in here. Hills, top, bottom. If you want to, another word is to think of is vertex. Back in the last chapter, the vertex was the top or the bottom, the maximum or the minimum of a parabola. Well, in here, these are multiple curves, right? But you can see there's a maxima right here, okay? Because the graph is, that's the top of a hill. Here's the bottom of a hill right here. That would be a min. Here's the top of a hill, that would be a max. Here's the bottom of a hill, that would be a min. Okay? So, where do I go from there? Well, what is the local maxima? The local maximas are x equals -4 and x equals 1. Top of the hill, top of the hill. Here's the two bottoms of the hills. This is not exactly, -3 is right here, so this is kind of our minimum. So let's call that -2.8, I guess, because it's between -2 and -3. And this one does look good enough to be at x equals 3. And now you can see -4, 1, -2.8, and 3 is how we came up with that second line. Okay? Which makes it really super easy because we can just look at our graph. We already determined increase, decrease, increase, decrease, increase because they're based from those hills, right? It is increasing, so I'm going to put an arrow up as I approach -4. As I go from -4 to -2.8, it's going downhill, so it's decreasing. From -2.8 to 1, it is going uphill, so it's increasing. From 1 to 3, it is going downhill, so it's decreasing. And from 3 on, it's going uphill, so it's increasing. And again, -infinity is over here, infinity is over here, and we're going to do the increasing intervals just like we did the positive and negative intervals, but they're different because positive and negative just means above and below. Increasing and decreasing means uphill and downhill. Two different things, right? This is uphill, this is downhill. Where is it uphill? Well, look, you already written where it's uphill. It's going uphill in those intervals. So from -infinity to -4, from -2.8 to 1, and from 3 to infinity. Where is it decreasing? Well, look, we'll put squares around those so that they're not confused. From -4 to -2.8, and from 1 to 3 is where it's decreasing. And that's what this is all about. Pause it a second. Look at what I did in number 9. Try number 10 on your own. I am going to go through it here. I'm not going to explain as much. I'm just going to keep writing as you go on. Check with what I'm doing. The zeros again are at, well, -4, 0, 2, and 4. So I'm going to take those points and I'm going to write them right here. And then I'm going to talk about increasing and decreasing. Here it is above this line, so it's positive. Here it's below the line, so it's negative. Here it's above the line, so it's positive. Here it's below the line, so it's negative. Here it's above the line, so it's positive. And then again, tells me my positive and negative intervals. My positive is from, again, this is -infinity over here, infinity over there. So from -infinity to -4, it's positive. From 0 to 2, it's positive. And from 4 to infinity is positive. Where is it negative? Well, where there again, there are negative signs. So from -4 to 0, and from 2 to 4. Okay. My local maxima and minima are again the bottoms of hills. This looks like, again, that's a minima at x equals -2.8. That's a minima at 3. There's a maxima at 1, and that looks like that's all there is. It's just minima, maxima, minima, nothing else. Now really, these lines keep going. There's like really arrows here, even though it says a point at it. I don't need this one, because I only have 3 of them, right? Let's put them in order. -2.8, 1, and 3. And what's happening? Is it increasing or decreasing? Well, from here, it's going downhill, so it's decreasing there. So I'm going downhill from the left till I get to -2.8. Then I'm going uphill till I get to 1. Then from 1 to 3, I'm going downhill. And from 3 on, I'm going uphill. So again, my increasing values are where they are arrows, up. From -2.8 to 1, and from 3 to infinity. Where is it decreasing? From -infinity to -2.8, and from 1 to 3. Because again, those are the arrows down, up, up, down, and so on. This is your notes. I know this is extensive. It's only almost 20 minutes of tape. But your homework is just the next 2 pages. So there's 2 graphs here, and then 2 graphs here. You can do 1 through 4 as your homework. Don't worry about the next page. That's something we're going to do tomorrow. Have a good day.